Hi, welcome to the session on mixers and replacements. To solve these mixers and replacement questions very easily, there is a standard formula. Before we understand that formula, let me explain this concept with a small diagram. So in the mixers and replacements, you'll be having a mixer. So let us say the mixer is full up to this point and it contains two components, A and B. And let us say the concentration of A is, let us say, IC, initial concentration. Now what we will do here is, in the next step, we remove some amount of this mixer from this beaker. So let us say the amount removed will be some X or whatever. But after you remove certain portion from this beaker, the concentration won't change. It is still remains the same, IC, right? Concentration won't change. So still it contains two components. In the next step, we add one of the pure component. See, when you remove the mixer out of this beaker, both A and B components will be removed because that is a mixer. Suppose let us say this mixer contains milk and water. Okay, milk and water. So if you remove this mixer, milk and water both will go out. But in the last step, we replace whatever quantity is being removed, we replace it with one of the pure component. That means either it should be pure milk or pure water. It doesn't contain anything. So that is very, very important. So we replace it with pure component. Pure component. Now what happens? The volume comes to the normal. But after addition of this pure component, the concentration changes, right? The concentration changes. Now it is no longer initial concentration. So it changes to some final concentration. So this is the working model of this formula. So now let us have a look at that formula. So the formula goes like this. So final concentration equal to initial concentration into 1 minus X by V whole power N. This formula appears to be very simple. So most students think that we can readily apply this formula, but there are certain things you should note down very carefully to apply this formula, because the questions will be twisted and most of the people commit a mistake in applying this formula. Okay, the first thing, what are these IC and FC? So these concentrations are the component A concentration or component B concentration in the mixer. That is very, very important. And what about X? So X is, it is given that one of the pure component, right? So what component we are replacing, that is very, very important. Now let me explain this formula first. Suppose let us say always start from X. Suppose in this question, if X is milk, okay, you are replacing it with milk, that is a pure component, then you should take FC and IC water concentrations. This is very, very important. If X is milk, so that means after removal of this mixer, you are replacing it with milk, then here FC and IC should become water concentrations. If it is being replaced with, if X is water, that means pure water is being added to this mixer, then IC and FC will become milk concentrations. Milk concentrations. This is also very, very important. Now, what about IC and FC? Always remember, initial concentration is always the concentration before you started adding the pure component. Here in this case, these two are same, right? Sometimes in the questions, without removal also they will add that mixer, correct? Add that pure component. Now in that case, you should always remember, initial concentration is the concentration of the mixer just before the addition of the pure component. That is very, very important. Also final concentration, the concentration immediately after the addition of the pure component. After that they may remove some mixer. You should not consider that one, right? So the concentration is the concentration immediately after the addition of the pure component, that is called final concentration. Now, what about volume here? Volume also, after the addition of the pure component, what is that volume? That is this volume, right? So this is also very, very important. So volume here is the volume immediately after the addition of pure component. So this is very, very important. So let me explain it once again. So otherwise you please refer to this video once again to understand each and every component written here, and try to understand this formula, in what context we need to apply. So what about X? If X is milk, in this case we need to take water concentrations, right? This is very, very important.